Okay, this is accelerometer mounted on a jet engine test sled. This is design example of accelerometer. It consisting jet engine, accelerometer cases, then guide rail, laminated test slat, and then gap. Okay, these all are configuration are features connected along with this accelerometer. Now we mean this accelerometer consisting one spring, mass, dashport or velocity. This setup is called accelerometer. Under the accelerometer having laminated test sled MS. This levitated test sled called another mass under the accelerometer. So we have two mass across this design example. One spring in front of this mass. After this mass, one dashboard is connected. So this setup going to be remain mechanical translation system. Now we are responsible to derive under the control of mechanical translation system. After derive this position or design, we will get a better result or better conclusion of this design. After solvation, we will get this design example graphical representation. Okay, we want to derive this means we damn sure know about mechanical translation system, mass formula, spring formula and dashboard formulas. That known category is very important. So mass always having m equal to d square x by dt square, then spring having k into displacement, dashboard having b into dx by dt. So these three formula going to be framed on differential equation. After that differential equation, we takes Laplace equation. That Laplace equation going to find out transfer function of this mechanical translation. This is the basic step of mechanical translation system. This mechanical translation system concludes this design example as a frequency graphical representation of accelerometer mounted jet.